Welcome back, Math 20-2. Today we're looking at your second lesson, quadratic functions, which is analyzing the graph. Now, if we remember, I kind of went over a bit yesterday, or the last class, on our graphs looking like a happy face, or a frown, a sad face, okay? And we're going to go back to that, and that's going to help us find our max and our minimum, and whether there is a maximum or whether there is a minimum. So I want you to think about it this way. If we are happy, good things will happen to you, right? You're positive, you are happy. Keyword there, positive, you are happy. And if you're happy, there's a minimum only on how sad you could get. There's a minimum on your happiness only. We are always happy. Like we're always reaching up, you're happy, you're feeling up there. There is no maximum to how happy you can get. Okay? Now, if we are negative and we have a sad face, well, that means there is a maximum to us how happy you can get. You're sad, there's a maximum. You're only going to get so happy because you're a sad person. But there is no minimum as to your onto how low you could go. So you could keep on going forever. There is no minimum. You could keep on going down, 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 down. Whereas if you're happy, there's no maximum to where you're going to go. Okay? So positive and negative. Now, why I say positive and negative, that has to do with our x squared, and that will deal with this a value here, as we'll find out later. So I strongly encourage you to do this part here, the basics of a graph. And this here will tell you how to graph it and how to find your max or your minimum. Okay, so it's going to go over which ones are positive, which ones are negative. Remember what I said, positive? If it is positive, if A is positive right here, what's going to happen? If you're positive, you're a positive person. You're a happy person. If your x squared is negative, you're not a happy person. You frown. There's not much happiness. There's a max to your happiness. And you just feel like going down, down, down. You're not going to be that up. Whereas if you're positive, greater, you're happy as could be. There is no maximum, okay? So I want you to think about that as we do some questions here. I strongly recommend going through this here, because this tells you how to calculate your max or min in a graph. Okay. So here we go. Class example says, consider the quadratic equation 2x squared minus 3x plus 15. State an appropriate window for that. Well, I look at this plus 15, I know it's going to be very high up. So my window, I'm going to say, is I'm going to put my y max here, or my y min, at, let's say 10. My y max, I'm going to put at 30, okay? Because I'm starting at 15. Now, what else am I going to look at? Or that's my y-intercept at 15. Let's try that. Actually, I'm going to go 0, my y min, and 30. My x, well, I'm going to have negative 10 all the way to 10. So let's try that. And put this in here. We're going to clear that. I know my x-intercept is 15, that's why I put it there. Now, first of all, this is a 2. It's a positive 2. So that means this person's positive. It's happy. It's not less than 0. He's happy. So I'm going to put this in here, and we're going to graph it. So I have 2x squared minus 13x plus 15. And I'm going to graph it. Let's see what it looks like. Ah, my graph looks like that. Well, isn't that interesting? This negative 13x really must have done something. Now, what does that do? This must mean it's downward. So let's take a look at it. We're going to go to my window. And we're going to put a negative 20. Ah, there we go. So, here is an appropriate window. I say my window is, my x values are negative 10, 10, and scale of 1. My y values, I should change my scales of 4 so I could count. My y values are going to be negative 20, 30, and my scale of 4. Because if I looked at this, now I could see my y value counting. Okay, so each of these ticks count as 4. So now it wants to know, determine the coordinates of the vertex. So how do I determine the coordinates of the vertex? Well, all we're going to do is do my max min. So I'm going to second calculate, and I want to go all the way down, oops, and we're going to find, in this graph here, there's a minimum. He's positive. There's only a minimum, how low he could go, and we're going to find it. We want left, so anywhere left, and then anywhere right of my minimum. So I did left first, now I'm doing right of my minimum, and now I'm going to guess. And it's around right there. Doesn't have to be exact. So I'd say my minimum is, my y value is 6.16, and my x value is 3.25. So we have, it's 3.25 is my x value, my y value is negative 6.125. Okay? So explain how to use the coordinates of the vertex to determine the equation of the axis of symmetry. Okay, so the symmetry, axis of symmetry, how can I use this? Well, my x value here is my axis of symmetry, isn't it? So the x value of the vertex is my axis of symmetry. Okay? Next part says determine the x and y intercepts of the graph. Well, how do we do that? There's two ways of doing it. We could either factor it, or I'm going to show you a simpler way on the calculator. We're just going to calculate my zeros. So I'm going to go second, calculate, and we're going to calculate the zeros. So we want to go left first. There's left, then right of the intersect, 4 curves, right, and then my guess is around there. I get 1.5. So I have 1.5 is 1. Okay? That is my x-intercept. Or 1.5. And what's the other one? I'm going to calculate. And I want my 0, because we want to know where is y0. So I go left. Here is left of the second intersect, and I go right somewhere. There's right, and then my guess, I get 5. Okay? Now, what about the y-intercept? So the y-intercept right here. Well, that is when x is equal to 0. When x is equal to 0, I take this equation, 2 to the power of 0, or 0 to the power squared is 0, times 2 is 0, minus 13 times 0 is 0, so it's just 15. Okay? Use the x-intercepts to verify the equation of the axis of symmetry. Well, to do this, is the x-intercepts verifying the equation of the axis of symmetry? All I have to do is I have to go 1.5, find the average of them, like the mean between them, and that should be it, plus 5, and we're going to divide that by 2. Okay? So I'm going to end up getting 6.5 divided by 2, which is equal to 3.25. So yeah, that does work. State the minimum value of the function. Well, what is the minimum value of the function? The minimum value is pretty much our vertex there. Okay, my minimum value is negative 6.125. Okay, state the domain and range of the function. So first of all, my domain, my graph looks something like this. It's a happy face. My domain is, it goes forever this way, and it goes forever this way. So domain, always for a quadratic, our domain is x is an element, we're looking at x, where x is an element of all real numbers. So x can be any number, that's what that means. And my range now, let's take a look at my range. My minimum is 6.125. So my range is, we're looking at y, such that y must be greater than or equal to negative 6.125. That's it. All right. Now let's take a look at example 2 here. It says, the line x equals 2 is an axis of symmetry of the graph this. Okay? Without using a calculator, algebraically determine the coordinates of the vertex of the graph. So my x equals 2 is an axis of symmetry. So we know when x is 2, that's my axis of symmetry. So that means my min is 2 comma something. That's going to be my minimum. So we put in 2 for x. So y is equal to 4 multiplied by 2 squared minus 16 multiplied by 2 minus 9. So I have 4 times 4 is 16, minus 32 is negative 16, minus 9 is going to give me a total of negative 25. And that is my vertex, 2 comma negative 25. That is it. All right. And that kind of makes sense because we know my y-intercept for this one is at, we know it's below, my y, it's a positive, and my y-intercept's at negative 9, right? Because if we put 0 in for x, so then it has to be below negative 9. So negative 25 is below, so that makes sense. Okay, so here they want you to investigate a little bit about the parameters, and it's which one's positive and which one's negative. And eventually we'll get to something like this. So for this, fill in the blanks. The shape of the graph is always a parabola. Okay, or a U-shape or a U-shape that way. U-shape up or down. Happy face or sad face. The graph is symmetrical about a vertical line called... So the graph is symmetrical about a vertical line called our... called our axis of symmetry. Okay, these are just some definitions. If a is greater than 0, the parabola opens. Well, if a is greater than 0, that means it's positive. It is happy. He is positive. So it opens up, and it makes a happy face. And the vertex is the, well, our vertex is going to be a minimum, because they can't be that sad. So it's a minimum. Because there's a limit. There's no limit to their happiness, but there's a limit on how down they can go. Okay, the y-coordinate of the vertex is the minimum value. Okay, now if it is less than 0, we are negative. This means it is negative, so we are opening down. Okay, and the vertex is the max. Oops. Because there's only a maximum is how positive they can be and how high and good you can feel. Now, the y-coordinate of the vertex is the max. Is our max value. Okay? Now, the domain of the graph is always x is an element of all real numbers. If c is greater than 0, the graph has a y-intercept of, well, if c is greater than 0, c is the last one, that means our x has a y-intercept of positive. So it's going to have a positive. If c is less than 0, our y-intercept is negative. Because basically, our y-intercept is c. Okay? So that's everything. Hopefully you understand this. Good luck with your questions tomorrow.